Welcome to Math 1324. This is section 4.1. We are looking at systems of linear equations. What that means is we have two lines. And so what can happen if we had two lines? Well, looking at this graph, here's line 1, the blue is line 2. They are intersecting in one common point. If we have the case of two lines being parallel, these two lines are never going to intersect. That means that there are no points of intersection. On a side note, how do we know if two lines are parallel or not? Well, if you look at their equation in y equals mx plus b form, if they have the same slope, then they will be parallel. The b is just where they are crossing on the y-axis. So, two lines could intersect in one point, never, or maybe in the rare case, I actually have the same line. They may look a little different in form, but they're actually the same line, and so they are intersecting in every point. So in question 1 here, what do we have? We have two lines. I've got y equals 1/3 x minus 4. Looking at that, I see the slope is 1/3. The line is going up. It is crossing at minus 4. And in the second line, I remember that. X equals a number. Anytime I have x equals a number, those are all vertical lines. Slope is undefined, and it's going to be crossing on the x-axis at 21. So, how do we solve that? Well, I can draw a graph, which I did here. So here's my line going up with a slope of 1/3 crossing at minus 4. And I've got this vertical line here, x equals 21. And I believe they are intersecting maybe at 21 and 3. So what do? I just substitute. I just plug the value of x in there and calculate. 1/3 times 21 is 7. 7 minus 4 is 3. So these two lines are intersecting in a common point, and that point is 21, 3. All right, in question 2 here, it says match the systems of equations below with its graph and use the graph to solve it. All right, so I'm looking at this. I'm thinking I'd like to use elimination, which means I want to multiply one of these equations by some number so that when I add them up, I would like to get one variable to cancel. All right, so I think I'm going to multiply the top one by 2. Why? Well, I've got a minus 3 there, and I've got a 6 there. Minus 3 times 2 would be minus 6, and if I add it to 6, that is 0. So I multiply all the way across, not just one number, but all of them, by 2. And so I get minus 6x minus 8y is 4. All right, so add them up. I've got minus 8 plus 5. That's a minus 3. 4 add a minus 5 is a minus 1. And now divide both sides by minus 3. Okay, got that. And so I find out that the y value is 1/3. Now I could plug that y back in and solve for x, or I could do the same trick where I got rid of the x's. I now focus on getting rid of the y's. I've got a minus 4 and a 5. I'm thinking if I multiply this one by 5, I'll get a minus 20. This one by 4, I'd get a plus 20. So when I add them up, I would get 0 for the y's, but I still have some x's. So I multiply the top one by 5, second one by 4. So because this is a minus, that's a plus. When I add them up, they go away. Let's see, 24 minus 15 is 9. Got a 10 and a minus 20, so a minus 10. And so x is a minus 10/9. And the y value I found was 1/3. All right, so that was our x value. All right, so, well, let's see which part of these graphs actually work. Well, not that one. I have more than one line. Let's see, this one doesn't look right. This one looks pretty good. The x part is a minus 10/9. Well, let's see, that looks pretty good. X part here is plus. Yeah, see, both of my x's are negative. So it can't be this because it's crossing at a positive x, positive x. This is a minus x and it's way down here. Let's see, how big is a minus 10/9? Well, a little bigger than 1, but certainly less than 2. All right, question 3. It says solve by substitution. So, what substitution means is I look at my two equations and I ask myself which one of these would it be easier to get a variable by itself? Well, I'm thinking if I move this minus y, I could have x by itself. So that seems good. So I do that. I move the y. It's a minus. It's now a plus on the right. And so what do? I substitute that into the other equation. So here's what I know about x. I'm going to plug it in. So it's y minus 5. Distribute. All right, I've got a 2y and a 6y, so a 8y. I'm going to move this minus 10 to the right. So it's a minus 18 plus 10. All right, that's a minus 8. Let's see, 2 and 6 was 8, so divide both sides by 8, and I get y is minus 1. Now, I can substitute this back in for x, so minus 1 minus 5, and I get x is minus 6. So these two lines are intersecting in one common point, which is minus 6 minus 1. All right, what about 4 here? Let's see, 2x plus 2y is 4. 2x minus 2y is also 4. Okay, well, let's see. Now, they didn't tell us a specific way. I guess they did actually. They said addition. We could use others, but addition is great. So, can I just add them up? Let's see, 2 and 2 is 4. No, that won't cancel. But 2 add a minus 2 does cancel. All right, so add them up. I don't have to multiply by anything. So 2 and 2 is 4. 2 minus 2 cancels. 4 and 4 is 8. So 4x is 8. And I get x equals 2. All right, so plug in x equals 2 into the first equation. So plug it in. See, I'm using the first one right there. So 2 times 2 is 4, plus 2y is 4. Move the 4 over, and then divide both sides by 2, and I get 0 over 2. Well, 0 over 2 is just 0, and so I get y equals 0. Now, just to refresh our memory, 0 over something not 0 is 0. And if I have 0 in the bottom part, that's really bad. It's undefined. Even worse if I've got 0 over 0. That is called indeterminate. All right, in question 5 here, we've got 2 lines, and they want me to solve it by elimination or by adding. So the first thing you ask yourself is, okay, let's look at the m's. I've got a 5 and a 1. If I add that up, that won't cancel. If I look at the n, I've got a minus 1 and a minus 5. If I add that up, it won't cancel. So what that means is if I want a variable to cancel, I'm going to have to multiply one of them by something, or maybe even both of them. Next thing, you have to decide, do you want to try to get rid of the m or the n? It really makes no difference, whichever way you find easiest. So what did I do? I multiplied the top equation by negative 5. Well, let's see, negative times a negative 5 would give me a plus 5, and yes, that would cancel. So multiply all the way across, don't forget that, by minus 5. All right, so minus 5 times 5, minus 25. Got the plus 5 in there, and I've got my minus 5 times 26, so a minus 230. So add them up. Let's see, minus 25 and a positive 1, so a minus 24. These guys cancel because of the alternation in sign. All right, if I add this up, I got a minus 144. So I need to get m alone, divide both sides by minus 24. Okay, well, what happens if I've got minus over a minus? Well, those cancel, and I end up with a positive 6. I take that, and then I plug it into either equation. All right, I pick the top one. So 5 times 6 is 30. 30 minus n is 26. Move the 30 to the opposite side. So 26 minus 30, or I don't want to do that. Then I have a minus in front of the n. Let's see, I think I'm going to move the n and then move the 26. So let's see, 30 minus the 26. I'm bringing that to the left, this guy to the right, making it positive, and so I get 4 is equal to n. So we are solving systems of two equations and two unknowns. What can happen again? Let's go back to the top. I could have my two lines intersect in a common point. Maybe they never intersect if they are parallel. And it might be the case that they are the same line but just look different.